What is going on, Algebra Bros? In this video, we're going to examine two graphs in a special way. Provided these graphs, we want to find the intercepts, and we also want to indicate whether the graph is symmetric with respect to the x-axis, y-axis, or the origin. So let's start with the graph in part A. The first thing that we want to do is identify any intercepts. So there are two types, x-intercepts and y-intercepts. This graph appears to be crossing the x-axis in two spots. And based on the values of the tick marks, looks like the spot on the left is -2, 0, and the other one would be at +2, 0. The graph does appear to cross the y-axis as well, namely at 0, -3. And these would be the intercepts of the graph. As for symmetry, let me show you how you can draw things out to determine which type, if any, that it has. Let's first examine x-axis symmetry. I'll make a little workspace for that. Now, if the graph has x-axis symmetry, then we're going to have corresponding pieces across from the x-axis. Now, using the graph above, I'd like to take a look at the pieces that are above the x-axis. And here's the technique. We're going to sketch out the reflected version of these two pieces. So we're going to have these two pieces pointing upside down now, and that would represent their reflection across the x-axis. So upon throwing these across the x-axis, we get ends that point down. And if we do the part that's underneath the x-axis in a similar way, reflecting it across the x-axis, we get the rest of the x-axis reflected graph. So what can we conclude about x-axis symmetry? Well, what should happen is that when you do this sort of reflection, if the graph has x-axis symmetry, then upon doing the reflections, we should get the original looking graph. Now, this doesn't line up with how the graph was presented to us initially. So I'm going to write doesn't match original, not match, and I'll say OG graph, which means no x-axis symmetry. Well, let's see if it has y-axis symmetry then. Well, our line of symmetry is the y-axis. And if we reflect the pieces that are above the x-axis, or, maybe in this case, it might be better to base our reflections across the y-axis. That way it's not totally confusing. And what I mean by that is, there's this piece to the right of the y-axis that when reflected across the y-axis will look a little something like this. And if we do the same thing with the piece that's to the left of the y-axis with our original graph, that would be the complete graph upon doing the y-axis reflection. Now, all things considered, should we draw this with 100% accuracy, we would find that this does match the original version of the graph. So this would have y-axis symmetry. I'm going to say matches OG graph, which implies y-axis symmetry, and I'll just cloud in y-axis. Now to see if it has origin symmetry, see if I can squeeze that graph over here. There are two reflections that you have to do. You have to reflect across the y-axis first, and then you take that piece that's reflected and you do a second reflection, which is across the x-axis. Now, let me draw the piece of the original graph that's in quadrant 1. If we reflect that across the y-axis, that will turn into that. But remember, there's a second reflection that we have to do, which is across the x-axis. So we'll take this green piece and now reflect it across the x-axis to get the final location of the part that started in quadrant 1. Now, keeping track of this, along with our original graph, focusing on this piece that's in quadrant 1, across the y-axis would line up with that part. Okay, that's no surprise because we know that this graph has y-axis symmetry, but if you go one step further and reflect across the x-axis, that piece would point upside down. And the final location of the piece that's in quadrant 1 doesn't line up with anything from the original graph. So this is another situation where our final graph after the reflections doesn't match the original graph. And that's how we can show that this does not have origin symmetry. So I'm just going to indicate doesn't match OG graph, which means no origin symmetry. Alright, so I think I'll cut the video off here. I'll do another one where we work out example part B. Alright, let me know if you have any questions in the meantime. Thank you.